In this problem, we want to find the distance between 2 points. So let me talk about this in general. If we have 2 points like this point, the coordinates are x1, y1, and another point here, the coordinates are x2 and y2. So the goal is to find the distance between these 2 points. So how far are these? Okay. And here we can create a right triangle. So this is the right triangle. And then we can look at the side lengths here. So this side length from here to here, this is the difference between the x values. So x2 minus x1. So that's this side length. And also the distance between this point and this point, this is the difference between y2 and y1. And now we have a right triangle. We can apply Pythagorean theorem. And the goal here is to find the hypotenuse. So this side, the hypotenuse, say this is d, the distance between them. So using Pythagoras theorem, d squared is equal to x minus x1 squared, the side length, the first leg length squared, and y2 minus y1 squared. So that's the distance between these 2 points. That's what d is. But in order to find d, we will apply square root to both sides. So I will eliminate the square from here and use a square root on the other side. This is a funny square root. Yeah, so that's the distance between 2 points. So in 2-21, so you can determine that the first point we have x1 and y1. And the second point we have x2 and y2. And then in part A, we can apply this formula, square root of negative 2x2 minus x1, that's squared, plus y2, which is 5, minus negative 6 squared. So d is equal to negative 2 minus the 3, that's negative 5 squared, so this is 25. And 5 minus negative 6, that's 5 plus 6 squared, that's 121. So d is equal to the square root of 6.46. So that's what we are going to do with part B, C, and D. In part B, so we can see that this is x1, y1, x2, and y2. And then again, we apply the distance between 2 points formula. So x2 minus x1, negative 3 minus 5, that's negative 8 squared, that's 64. Plus 1 minus negative 8 becomes 1 plus 8, that's 9 squared, 81. So d is equal to 145. And here again, we have x1, y1, x2, and y2. So d is equal y2. D is equal x2 minus x1, 5 minus 0 squared, that's 25. Plus y2 minus y1, so 0 minus 5, that's negative 5 squared, that's another 25. So this is the square root of 50. And in D, we want to write the distance you found in part C in a simplified square root, which means here we can 25, we can write 50 as 2 times 25, because 25 is a perfect square, which means its square root is a whole number. And now we have square root of 2, square root of 25. So this is just 5. 5 times square root of 2. We write it this way. So that's the answer to part D.